let's start with question 1. Okay. So you're given a coin that's biased so that the probability of obtaining a head is 0.25%. And then you have another coin that's biased so that there's a probability of getting a head for 0.6%. I mean, not percent. So you want to find the probability of obtaining at least one head. So we can use complementary counting to solve this problem. Oops, I spelled it wrong. Complementary counting. So basically what complementary counting is, you take the probability of everything, which is just 1, and then you subtract the probability of what you don't want. This is also called the complement of what you want. Complement. So in this case, the probability of what we don't want, well, we don't want to obtain 2 tails. Yeah, 2 tails or 0 heads. Wait, what? No. What we don't want is to obtain 2 heads. And this is the same as flipping 2 tails. So the probability of flipping 2 tails for these 2 coins is just, for the first coin, it's 0.75. The probability is 0.75, and then the probability of flipping the other coin as the tails is 0.4%, not percent. So this is the probability of what we don't want. And we subtract that from 1, and we will get 0.7. This is equivalent to 70%. And that is your answer. Hello, Michelle. What are you confused about? Okay. So complementary counting is it's always in this format. This is always kind of like the formula of how to get a counting thing. You mean the probability? Okay, look. To obtain tails for the first coin, it's just the probability is 1 minus the probability of rolling heads, because coins you only have 2 options for flipping coins, heads or tails. So that's where the 0.75 comes from, and then this comes from the second coin. To flip tails, you have to the probability of flipping tails is 1 minus the probability of flipping heads, which is 0.6. So that's where 0.4 comes in. Okay. No problem. All right, let's move on. Next question is, okay. So we want to find the area of this shaded region, or the triangle. So we know, first of all, we know that the y-intercept is at -9 over here. And then we know that the x-intercept, well, we can find the x-intercept. So we're given the formula of the parabola. So if we set this parabola, f of x, to 0, then we can find the x-intercept. So we just solve for x, and that will give us positive -3. So we know that this point is -3, this is 3, and we can find the area of the triangle from that. So we know that the height of the triangle is 9 from the y-intercept, and we know that the base is just 3 plus 3, or 6. Knowing that, we'll just use the formula of a triangle, half times base times height. That will give us an answer of 27. So this next problem might be a tad bit trickier, but it's okay. So first of all, you're given a radiator with a capacity of 9 liters, and right now it's 30% of it is filled with antifreeze, whatever. And you want to make it so that it is 65% antifreeze. To do this, we're gonna use fractions to solve for this, and to set it up, the top of our fraction is going to be the amount of the amount of antifreeze in it in liters, and then the bottom is just the total capacity in liters. So we know that the total capacity is just 9 because it's stated in the problem. So we want to find our final value that we want to get is 0.65, because that's what it's asking here. And to get 0.65, we have to first, let's find how much antifreeze is initially in this tank radiator. So that's just 9 times 0.3. 0.3 is from this thing because it's stated in the problem. Yeah. And then the 9 is just the capacity. So we have to remove some of the mixture, and then we have to add pure antifreeze. So let's just let X be the liters of pure antifreeze. AF antifreeze. So we're to remove some of the mixture. Every time we remove some of the mixture, we're actually removing 0.03 times X of antifreeze, because the mixture isn't pure. The initial mixture isn't pure antifreeze. So that's why we need to include this decimal thing in there. And then when we're adding pure antifreeze. So that's just X. And if we cross multiply, we can find that 5.85 is equal to 2.7 plus 0.7x. And we just want to solve for x. So if we subtract 2.7 from both sides, we'll get 3.15 is equal to 0.7x, and x is just equal to 4.5 liters. And that is your answer. Question 4, 5 minutes left. Let's speed through this. Okay. First of all, let's just let x be the 13th even term. So now we're just going to write out an equation for this first sentence right here. So if x is the 13th even term, then that means x plus, not n, sorry. X plus 2 will be the 14th term. And then on the other side, we have x minus 2. This is the 12th term. And then the 15th term will be x plus 4. And then the 11th term will be x minus 4. So we're adding in increments of 2 because we want to find the sum of 25 consecutive even terms. So we're not counting the odd terms, so we're just skipping over them. And then we're going to add this all the way up to x plus 24, and this will be your 25th term. The same thing on the other side, but negative. This is your first term. And if you add all of these up, you'll notice that this, all of this will cancel out, leaving you with just 25x. And that is equal to 10,000. So now we can solve for x. We'll find that x is equal to 400. And that means our 25th term, is just equal to 400 plus 24. That will give us 424. Okay, last question. So I already drew out the whole picture for you. And the important thing to note here is that whenever Charlene crosses whenever she hits a corner, she's gonna make an arc, like an arc shape thing where she can see stuff, okay? And that's just important to note. And all of these, every time she hits a corner, she'll make like 1/4 of a circle kind of thing. And we just want to find the blue shaded region that I drew. And to do that, let's just first find the inside of her walk. But by the way, she's walking on the black square right here. And the inside of the walk, which is this thing, the area of that is just 5 squared minus 3 squared. That will give us 16. And then the outside, well, first let's just find these rectangles. So these thingies. And those are just, the area of those is just 5 times 1. And then there are 4 of those. And then we add all of the quarter circles. And there are 4 quarter circles, so that will make 1 whole circle.